Hello, let me introduce myself. My name is Andrei. I am from Krasnoyarsk. The topic I took from the list sounds exactly like Docker microservices. Docker containers and microservices have become more or less analogs to powering the cloud. It is also a solution to come to speed up with the rest of the new software that is being developed currently. Also, there is a lot of enterprises that is moving completely to the cloud with these technologies. Before microservice, I'd like to tell about containers, but before it about virtual machines and how containers differ from them. A virtual machine exhibits a behavior of a separate computer. If we have to emulate different operating system in one machine, that is called making a virtual machine. A hypervisor manages these virtual machines. Hypervisor itself is an operating system. It's run on host, so if we need to run our application independently with all required environment, we have to run virtual machine with installed operation system and all environment, and the same for other application and for other. The main disadvantage of virtual machine is that it requires host resources for its guest operation system besides the application and the necessary binaries and libraries. The container that will run application, not the guest operation system, is a good alternative. That is the difference between virtual machine and containers. Docker provides such technology. As it said in official documentation, Docker is an open platform for developing, shipping, and running applications. Docker enables to separate application from infrastructure so the software can be delivered quickly. With Docker, you can manage your infrastructure in the same way you manage your application. By taking advantage of Docker's methodologies for shipping, testing, and developing code quickly, you can significantly reduce the delay between writing code and running it in production. Docker provides the ability to package and run an application in a loosely isolated environment called a container. The isolation and security allows you to run many containers simultaneously on a given host. Containers are lightweight and contain everything needed to run the application, so you don't need to rely on what is currently installed on the host. You can easily share containers while you work, and be sure that everyone you share with gets the same container that works in the same way. Docker provides tooling and platform to manage the life cycle of your containers. Develop your application and its supporting components using containers. The container becomes the unit of distributing and testing your application. When you already deploy your application into a production environment as a container or orchestrated service. This works the same whether your production environment is a local data center, a cloud provider, or a hybrid of the two. It can be said that Docker has another two advantages. Responsive deployment and scaling, it's one, and the second is running more workloads on the same hardware. Let's say a few words about Docker architecture. Docker uses a client-server architecture. The Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and the daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. The Docker client and the daemon communicate using REST API over Unix sockets or a network interface. Another Docker client is a Docker Compose that lets you work with application consisting of a set of containers. The Docker daemon listens for Docker API requests and manages Docker objects such as images, containers, networks, and volumes. Daemon also communicate with other daemons to manage Docker services. The Docker client is the primary way that many Docker users interact with Docker. When you use commands such as docker run, the client sends their commands to a Docker daemon, which carries them out. The Docker command uses the Docker API. The Docker client can communicate with more than one daemon. Docker registries. A Docker registry stores Docker images. Docker Hub is a public registry that anyone can use, and Docker is configured to look for images on Docker Hub by default. But you can even run your own private registry. When you use the Docker pull or Docker run commands, the required images are pulled from your configured registry. When you use a Docker push command, your images is pushed to your configured registry. When you use Docker, you're creating and using images, containers, networks, volumes, plugins, and other objects. An image is a read-only template with instruction for creating a Docker container. Often an image is based on another image with same additional customization. For example, you may build an image which is based on the Ubuntu image, but installs the Apache server and your application, as well as the configuration details needed to make your application run. You might create your own images, or you might only use those created by others and publish it in a registry. To build your own image, you create a Docker file with a simple syntax for defining the steps needed to create an image and run it. Each instruction in a Docker file creates a layer in the image. When you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. This is part of what makes images so lightweight, small, and fast when compared to other virtualization technologies. A container is a runnable instance of an image. You can create, start, stop, move, or delete a container using a Docker API or command line interface. You can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. Now a few words about microservices. The microservices architecture is emerging as an important approach for distributed mission-critical application. In a microservice-based architecture, the application is built on a collection of services that can be developed, tested, deployed, and versioned independently. In addition, enterprises are realizing cost saving, solving deployment problems, and improving DevOps and production operation by using containers. And the Docker container engine used de facto as standard. Opposite for microservices is monolith application. Monoliths are usually hard to maintain over time. You won't be able to fix an error in a monolith application if you don't overhaul the entire application. Microservices are meant to do one thing only. That is, you can assign each microservice a particular task. You should be able to shut the images down and spin them easily without disrupting other work streams or action. Microservices are also language agnostic. Microservices don't tie you to one stack and saves you on a lot of dependency issues. This cannot be done in a monolith application. You cannot run the same application that requires 5 or 6 different libraries that expect different versions. Microservices can solve multiple dependencies in a complex application very easily. Orchestrate everything in a way that you are running multiple runtimes and libraries on one machine. They are all independently updated and upgraded components, and you won't have to change the overall application, just the task items that you want. In vertical scaling, if load increases, you might have to upgrade machines and servers. Vertical scaling is hard to implement. As an example of horizontal scaling, you can open an Amazon page. A few hundred microservices are invoked at the same time. Catalog browsing is one microservice, product availability is another, and so on. The microservice can figure out if load is more or a particular item has more demand, and then based on that information can spin up more containers and scale the application horizontally. Microservices fit nicely with the Docker paradigm. Docker allows you to build those microservices and help you move towards the microservices architecture. With its rising popularity and easy of use, everyone is trying to convert outdated application into microservices-based architecture. That's all. Thank you for your attention.